type of problem called limiting reactant problems, where I'll read the question first. If you begin with 16.07 grams of aluminum and 8.8 grams of oxygen, how many grams of aluminum oxide can be formed? So we have grams, which we can convert into moles of aluminum. And then we have grams of oxygen, which we can convert into moles of oxygen. And so anytime you can find moles of two reactants, let's see if I can zoom out a little here. There we go. It is a limiting reactant problem. And my abbreviation for limiting reactant is capital L, capital R. And for limiting reactant problems, you have to find the amount of product for both reactants and then choose the smaller one. Let me take you through that process. Let's start with 16.07 grams of aluminum. And we're going to see how many grams of aluminum oxide we can make using the molar masses. Using our mole to mole ratios, now 4 moles aluminum for every 2 moles aluminum oxide. And then back to grams. For aluminum oxide, it looks like 2 26.98, 2 times 26.98 plus 3 times 16. I get 101.96 grams per mole. So 1 mole aluminum oxide is 101.96 grams of aluminum oxide. And I'll do my math and then write my answer down below this. I get 16.07 divided by 26.98 times 2 divided by 4 times 101.96. I get 30.4 grams. Aluminum oxide. And this, what I'm going to write for my next note here, is part of the thought process, meaning that 30.4 grams of aluminum oxide can be formed before we run out of aluminum. And assuming we have excess oxygen. That's sort of the whole statement that goes with this calculation. Now let's do something similar for our 8.8 grams of oxygen. Start with 8.8. Do the same process, meaning turn grams into moles. You do a mole to mole ratio from 3 moles of oxygen reacted to 2 moles of aluminum oxide. And then last but not least, go back to grams, which is really just a copy of this last step. And there are a number of ways to do limiting reactant problems. This is how I do them. You can do them different ways. Just make sure that when you write down your work for these, that you show your work and everything will be good. Multiply everything across, multiply and divide, I should say. For this, I get 8.8 grams divided by 32 times 2 divided by 3 times 101.96. I get 18.7 grams of aluminum oxide can be formed before we run out of oxygen. And let me pull that up a little bit. And assuming we have excess aluminum. Okay. Any questions so far on what I have? All right. Well, here's how these always work. Your answer is always the smaller amount. Right, and that's always true. So your answer when you do this is always the smaller amount. And so that's how we know what our answer is, and you would have to enter in 18.7 into Blackboard for this problem. Further, we can say that O2 is our limiting reactant. And so at the end of this reaction, there will be no oxygen left over. And some aluminum will be left over. And in separate problems, we'll ask you to figure out how much aluminum is left over, but we're not there yet. So, any questions about this? This is a long problem, and problems are getting longer, but we're doing it step by step, so hopefully it makes sense.